Today we get to start a brand new chapter, an entire chapter dealing with percent problems. We have percent change, tax, tips and markup, discounts, interest, commissions and fees, and percent error. That's an awful lot of percents, and we're going to learn them all, starting off with Lesson 1, Percent Change. The objective is that students will solve problems involving percent of increase and percent of decrease. Suggested pacing says this is going to be a 2-day lesson, so we get one night without homework and one night that you get to expand your mind even more. If you take a look, we're picking up 3 new vocabulary words in this lesson: percent of change, percent of decrease, and percent of increase. Have you ever discussed in your class how the cost of living increases over time? I'm sure your folks have talked about it at home. Have you ever heard of this little thing called inflation, something we're seeing an insane amount of right now? In economics, inflation is a continual increase of prices of goods and services. This is why the cost of going to see a movie seems to increase each year. Select the ticket prices to reveal the cost of movies in 3 different years. So, the first ticket price, I guess we're going to click right here. In 1985, back when I was still younger than you guys are now, still older than you guys are now, was $3.55 for a ticket. In fact, I still remember the dollar movies where we'd go and it cost us a whopping $1 to go see the movies that were no longer in the $3.55 theaters. 2000, it was up to $5.39. In 2015, it's up to $8.17. And I think now it's somewhere in the neighborhood of $13, $13.50, something of that nature per ticket, which makes it pretty dang expensive to go to the theater to watch a 2-hour show, particularly if you take in a whole family. Select tickets prices. Yep, we have no idea what that's for. How much did the ticket cost increase from 2000 to 2015? How does the amount of increase compare to 2000? These are things that we're going to be learning about in this lesson on percent change. For an introductory and inquiry question, they ask, how can you use percent change to describe a change when a quantity increases or decreases? And apparently somebody's buying some camping equipment, so we will see what happens here. Suppose a tent is on sale for $80. After the sale ends, the price increases to $96. By how much does that price increase? Well, what's the difference between 80 and 96? That is, of course, going to be $16. Check our answer. That one checked good. Next, the bar diagram represents the original price, $80, at 100%. The original price was $80, the new price is $96, and the price increased by 16%. From here, we're going to take that $80 and divide it by 16, and that's going to give us 5, which dividing by 16 is because of this value right here. It said the price increased by 16, and when you divide by 16, you get 5. And then we're going to press a button, and that's going to divide the bar graph into 5 equal sections. Each one of these sections represent a $16 increase, and each one of those sections represent a 20% change. You good with me so far? So, with that question in mind, what percent indicates the increase in price? Well, let's go back to where we were here. The increase was $16. What percent did that match up to? That matched up to a 20% increase. So you could say that you increased the price of the tent by 20%. Now, a bar graph is not the best, most friendly way of doing this, and I'm hoping our textbook is going to show us something else very soon, but we shall see. Now, we're going to learn how to use the same bar diagram to show the new price of 96%. So we're going to take and add 16%, $16, also known as 20%, to the bar diagram where we'd had $80, now we get $96. And what's our percentage? It's 120%. So the new price is 120% of the original price, and it is a 20% increase off the original price. Now, a sleeping bag at the same store sells for $60. The manager changes the price to $45. How much does the price decrease? This time we're dealing with percent of decrease. So how much is our price decreasing? That's right, 60 minus 45 is going to be 15. With that information, we've got our bar diagram. We know that $60 represents the whole, 100%, the original price. $60 is 100% of the original price. On our what we know box, we have original price is $60. We have the new price is $45, and the fact that the price is decreased by $15. So how are we going to break it down from there? Well, we're going to take that 60 and we're going to divide it into $15 sections. So if you divide 60 by the $15, that gives you 4 sections. That means we have to divide our bar diagram into 4 sections, just like you see there. Our first section, $15, is 25%. That means that 50% would be $30, and 60% would be, 75% would be $45. So by doing that, you can fill in the different parts, and I think we're going to see that right here. The percent indicates what percent indicates the decrease in price? Well, it decreased by $15, also known as decreasing by 25%. And now we're going to hopefully fill in the rest of the bar diagram. So you can see here, 75% was $45. It is 3/4 of it is shade, so we're doing 75% of the original price to get to the new price. Once again, this is using a bar diagram to find percent increase and decrease. There are some other ways to go about this. Now, how can you use a percent to describe change in quantity when a quantity increases or decreases? Well, we kind of explained that already. I showed you talked about how the first one, the tint, was increased by 20%, and it was 120% of the original price. So that's just one example of how we can use percent to describe increase or decrease. And with that, we are ready to learn our first 2 vocabulary words. The first one, percent of change, is a ratio written as a percent that compares a change in quantity to the original amount. That is pretty much word for word how your vocab quiz is going to be written for that one. And then if the original amount is in an increase, it is going to be called a percent of increase. Now, your vocab quiz is a little differently worded, and if you go back and look at that study sheet I gave you on the very top of Module 2, it'll show you exactly how I'm going to word that vocab term for your upcoming vocab quiz. The price is of monthly internet increase from $36 to $45. You can use a bar diagram to determine the percent of increase. Move through the slides to see how to use bar diagrams to find the percent of increase. So you can see they have the bar diagram set up. The original price, 100% of the original price, was $36. From there, it went from $36 to $45. So they took and said, well, hold on, they subtracted 36 from 45, and that gave them 9, okay? And then they said, well, $36 divided by 9, that's going to be 4, so they broke it down into 4 different individual sections. And you can see they've explained all that down here. They said that you have an increase of 9, and then they said they divided the 36 by the 9 and gave them 4, and that led them to getting 4 equal size sections of 9 each right there. Okay, we good with where these 4 equal size sections came from? Because all 4 combined were 100%, That means each one of them is going to be 25%, and each one of them represents $9. So that increase is now we're at 125% of the original price by adding that $9 to it, which meant that the price increased by 25%. It was a 25% increase, and the new price is 125% of the original price. If you multiply the original price by 1.25 or 125%, you're going to get the new price. But we'll talk more about that in a little bit. When finding percent of change, why is it important that the two quantities have the same unit of measure? Well, if you don't have the same unit of measure, it's going to get ugly really fast. So we're not going to dig too deep into that one. So let's look at a percent of increase problem. The enrollment at a middle school increased from 650 students to 780 students in the course of a 5-year time period. What is the percent of increase in the number of students enrolled at the school? Well, first question, by how many students did the enrollment increase? 780 minus 650, what's that answer going to be? 130. So we know that we have an increase of 130 students. We know that 100% of the original amount was going to be 650. Now we're using bar diagrams to represent this again. 100% of the original amount is 160. We know that we've increased by 130 students. Wow, they just threw a whole bunch of words in there, didn't they? How did we get 130? Because we found the difference between 650 and 780. That's 130. Now you see they broke it down into 5 different sections that are already shaded to represent the 100%. Why did they do 5 sections? Because they took and divided 650 by 130. They divided the original amount by the amount of change, 130, and that gave them 5. That told them they had to divide their 100% bar graph into 5 equal sections. Each one of those sections represents 130 students. And of course, 100 divided by 5 is 20, and that is where this 20% came from. From there, next thing they're going to do is say, okay, well, they did 20%, so now it's time to take and find out what the final percentage is. If each section of 130 students equaled 20%, that means the new section equals 20% as well. So the enrollment increased by 20%, and you would say that the new amount of students is 120% the original amount of students. A 20% increase, though, that's what the final answer you're really looking for on this one. Now that was method 1 using the bar diagram. As I've said before, it's a great visual representation, but it's an awful lot of work to get to the right answer. Instead, there's other ways to do it, and method 2 they're going to show us is using equivalent ratios. The first step of using equivalent ratios is to identify our part and our whole. So I'm going to scroll down just a little bit. Our next slide shows your original amount was 650. Your new amount was 780. 650 is going to be your whole. 780 is going to be the whole plus the part. And the part, that's going to be the 130. So we got that part down. We already discussed where that 130 came from. We got it when we subtracted 650 from 780. Next, we can take and find the percent of increase, also known as the percent of change. The percent of increase or percent of change, wow, they just threw a whole bunch of stuff here. Now I'm going to break down what they did, so we're going to take a screenshot, and now we're going to look at it. And this here isn't even my preferred method, but this is a cool thing they're showing us here. So they set it up where they had a ratio of the part to the whole. So you have part over whole right here. The part was 130. The whole, the original whole amount was 650. If you were to divide that out, if you were to do the long division, remember in long division your first number goes in the house, your second number goes outside the house. Well, first off, instead of dividing those, I'm going to take those zeros and knock them off the end because I know I can do that. That's the same thing as dividing by 10, and that's going to make my number a whole lot easier to work with. Now I have 13 divided by 63. 63 goes into 1 0 times, it goes into 13 0 times, and it's a decimal and a 0. Your decimal goes up, and 63 goes into 130 2 times. And when you multiply that out, you can do, I'm sorry, that should be 65, not 63. 2 times 5 is going to be 10. 2 times 6 is going to be 12, plus 1 from the 10 is going to be the 13 with nothing left over. And that is where the 0.2 came from, also known as 0.20. And you can take and change a ratio, or you can read that number, that is 20 hundredths, 20 over 100 right there. And a percent is a ratio of some number to 100, so our final answer is going to be 20%. Now once again, let's go back and look at it. We compare the part to the whole, 130 to 650. I got rid of my zeros on the end and did my long division, and that gave me 0.2. Also known as 0.20, which is 20 hundredths, 20 over 100. A percent's a ratio between some number and 100, so it's going to be 20%. We go back to our original problem, put in 20%, check it, and it checks correct. So you can say the percent of increase in student enrollment is 20%, the same answer we found when we used the bar diagram method. Our talk about a question is, why is the whole 650 and not 780? Well, the 650 is where we started. So your whole is always going to be your starting point. You add your percent of change to the starting point, and that gives you your new amount. So the new amount is not the whole, it's not the original amount. Now this video is getting a little long, so we're going to stop right here. And when we come back, I'm going to show you my way of doing this. I'm going to introduce you to a formula for solving this. I like the formula method better, and to me it just makes the whole world a lot prettier place. But we're going to come back and look at a formula method for this that you can use for finding lots of different pieces of this problem down the road. See you on video part 2.